Hello, welcome back to Dimming Stage Block 9 and 1d8 plus 1 lunar orbs. There in the beginning, there was a Big Bang Theory. And it had red light and blue light pulsars type thing, closer to the Big Bang origin of 13.6 billion years ago. Closer you get to the red light shift type thing of light type thing. And that makes, along with red light, gravitational that affects the wavelength to make it look red or blue depending on its relative point. And with this crew of the Star Trek Enterprise, we can turn to Kirk and Spock of the crew to consider interstellar travel. And that's another picture of the Starship Enterprise. And in that type of sense, that's the flying saucer, the top part of the Enterprise type thing looking like a flying saucer. And from there, we've seen a lot of flying saucers being considered in interstellar travel. Saucers kind of go back to old school movies, cups and dishware of saucer. That's a saucer plate, and even though it carries a coffee cup, and from that type of thing, it's a mainstay apparently there, and it's microwavable safe. And you've got two plates there, or two saucer plates, and you can consider bringing them together, and they could almost stack on each other. Or in that type of sense, you could consider making them flip over type thing, and that would make them like a UFO or a frisbee. And with the merry-go-round type thing, in that type of sense, you can build up speed of rotation or slingshotting like a discus thrower type thing, and then consider from there throwing your discus around the sun, just like Star Trek 4, The Voyage Home, to slingshot through time and move at the speed of light, and like a wormhole escape type thing and travel through time, or in that type of sense, use a flying saucer. From the flying saucer, you need to pick a star type thing, and we've got a lot of stars out there in the universe. But in our system type thing, we might consider either our Earth or we might consider our Sun, just like Star Trek did, to move at the speed of light. From moving at the speed of light, we could then consider looking at the whole equation of the redshift gravitation. That equation involves Einstein's tensor, or vector, of his relativity and Newtonian physics to try to slingshot around the solar system, much like NASCAR drafts around a curve, to a star destination, say like the Proxima Centauri, and then use the Schwarzschild radius equation, except for the 1 minus stuff, in that type of thing, because it makes very, very small numbers in there. But we're going to use part of it type thing here, along with the G gravitational constant, not at 10 to the minus 11, but 10 to the 11th, and the mass of planets, the Sun at 10 to the 30th, and the Earth like 10 to the 24th, so that we can move at the speed of light in interstellar travel through that formula type thing, and the radius of 3 Schwarzschild radius, the radius in between the Sun and the Earth. And that is going to be 10 to the 11th as well as 10 to the 30th, and that's the mass of the Earth, and 6.67 times 10 to the 11th type thing there, to calculate from the Newtonian physics and fill in those variables. And we're going to take those variables and put them back into the Schwarzschild radius or redshift gravitational equation. 2gm divided by c squared r. It should be by the mass of the Sun in formula of 2gm divided by the mass of Earth in 2gm. But I think that also makes too small of a number. Just use the mass of the Sun. So that's 2.667 times 10 to the 11 times 1.99 times 10 to the 30th divided by 3 squared. Speed of light 10 to the 8 and some other constants there. And you're going to get 10 to the 41 on top divided by 10 to the 27th power. And you also had the radius in 1.496 times 10 to the 11, which is 3r type thing, from the Schwarzschild radius type thing. And you're going to end up with a 0.6913 times 10 to the 14th, or 6.913 times 10 to the 15th. And you're going to try to relate that to a parsec type thing in astronomical units. And that is going to be, let's see, 6.913 times 10 to the 15 divided by 30.857 times 10 to the 15 meters in a parsec, giving a value of, let's see, 20, it should be 1 over 5. Should be. And that's going to give a 0.224 parsecs type thing in that type of sense. X, which is equal to 1 parsec, or 2626, 4,621.3 astronomical units. And then I tried to solve for astronomical units. And I got 0.073 light years, and the square root of that is 0.73 light years. Cancel out my units, type thing in that type of sense, and go back to the Schwarzschild's relationship to realize type thing and that type of thing that we took the square root of the inside of just the numerator part of that 1 minus for the sun type thing in that type of sense, and skip the bottom part type thing, and then it is 1.30 parsecs to the Proximity Centauri system divided by 0.224. It's 4.24 light years away to divided by 0.224 parsec speed of the ship. It's 1.30 divided by 0.224, and that is 5.8 light years in relation to getting to Proximity Centauri. So it should take, light years is the amount of speed of light going 186,000 miles per second, or 2.9 times 10 to the 9th meters per second. It's the amount of time for light to travel to that star type thing. And at that speed that we're going, which is at 2 million miles over 300 million miles type thing, that's 2 divided into the top part. 2 divided by 2 is 1. 2 divided into 300 is 150. So that's 1 over 150. That is 1/150th the speed of light through the slingshot of gravity from the sun, unless we find a bigger star or bigger solar system. And in that type of thing, it would take, at that speed, 5.8 years to travel at that light speed to get to roughly 2 million meters per second, or 671 miles per second type thing. So in the time that it takes for somebody to do a speed skate type thing, and that means of like 30 seconds, that would be 30 seconds times 671 miles per second type thing in that type of sense. And that's how many miles they went. That's how fast it would be going. That might be relative type thing. America is 3,000 miles, so it would take 5 seconds to travel the distance of America at 671 miles per second. 5 seconds cross out, so it'd be 5 times 671. That's 3,000. That's 5 times 600 basically, and that's 3,000. So that's 3,000 miles in 5 seconds. And that concludes interstellar travel concept of Gene Roddenberry and of Star Trek, and thinking of the gravity and Einstein's gravity well from his general relativity, of how time travel, or in that real sense, I guess a little bit closer type thing, is how his light measurement astronomy was pulling the gravity of the light and giving it a curvature, thus being relative type thing is his theory in amongst the star science. That's how he developed his theory, and did that around an eclipse, and saw the gravity around the sun type thing, and was able to take slides of it and recalculate the light bend around it, and realized that the light didn't bend at the same rate closer to the sun as it was as further away. So the gravity of the sun was pulling the light waves in. And that's his general relativity theory. So thanks for listening, and have a great one.